Now let us discuss analysis and complexity of algorithms. To compare different algorithms, we use something called running time. Running time is the time taken by an algorithm to produce the output. An algorithm is considered better if it takes less time to solve a problem. Instead of measuring actual time in seconds, we measure the number of operations performed by the algorithm. We represent the running time as a function t of n, where n is the input size. This running time is also known as the time complexity of the algorithm. So, we can compare algorithms based on their time complexity. An algorithm with smaller time complexity is considered more efficient. That's the basic idea of analysis and complexity of algorithms. Now let us look at the generalized running times of algorithms. First, constant time. In this case, the running time does not depend on the input size. It always takes the same amount of time, so it is the most efficient. Next, linear time. Here, the running time increases proportionally with the input size. If the input increases, the time also increases linearly. Now, logarithmic time. In this case, the running time grows very slowly. This happens when the input size is reduced at each step. Next is quadratic time. This usually occurs when there are two nested loops. Each loop runs n times, so the total becomes n squared. Then we have cubic time. This occurs when there are three nested loops. So the running time becomes n cube. Next is polynomial time. Here, the running time is a polynomial function like n, n square, or n cube. These are generally considered efficient. Now, exponential time. In this case, the running time increases very rapidly with input size. It becomes very slow for large inputs. Finally, factorial time. This is the fastest growing running time. It increases even more rapidly than exponential time and is not practical for large problems. Now let us understand the complexity of an algorithm. The complexity of an algorithm is represented as a function f of n, where n is the size of the input. It tells us how much time or space an algorithm requires to solve a problem. In most cases, the space required is proportional to the input size. And generally, when we say complexity, we are referring to time complexity. Now, there are three types of complexity analysis. First, worst-case complexity. This represents the maximum number of steps an algorithm can take for any input. It gives us the upper bound of running time. Next, best-case complexity. This represents the minimum number of steps taken in the most favorable situation. It shows the fastest possible execution. Finally, average case complexity. This represents the average number of steps taken over all possible inputs. It gives a more realistic measure of performance. So, these three cases help us analyze and compare algorithms effectively.